What's up everybody, welcome to another video, and I hope you're ready to flex those brain muscles. In this video I'm going to solve some problems involving parabolas, and these are problems where we're looking at parabolas from a geometric perspective rather than an algebraic perspective. So we're looking at the focus, directrix, all that kind of stuff. And so what I did is I put some example problems into a worksheet, and the link to this worksheet will be in the description below. So you can check it out, follow along, or even better yet, try some of these on your own first. And I'll put timestamps in the description to each problem that I solve. And hopefully this will help you feel more confident to solve some of these on your own when you take your exam. So before I jump into the first problem, I do want to kind of look at the general formulas and just talk for a quick second about what exactly we're dealing with here is, in case y'all haven't looked at this stuff in a while. So here are the general formulas of the parabolas we're dealing with, and what I first want to point out is the information we can gather by just looking at the equation of a parabola if it's in this form, right? And the first thing we can gather is whether the parabola opens up, down, left, or right. And this is dependent on whether the x term is squared or the y term is squared, as well as whether we have a plus or minus, right? So a positive or negative coefficient. So if our x term is squared, then we're either opening up or down. If our x term is squared and the coefficient is positive, we open up. If our x term is squared and the coefficient is negative, we open down. Similarly, if our y term is squared and our coefficient is positive, we open to the right. And if our y term is squared and the coefficient is negative, we open to the left. And this actually is consistent with how we looked at parabolas from a more algebraic perspective. Like if you remember graphing something like y equals x squared, this parabola opens up, and it turns out this x term is squared. We have a positive coefficient, so it is consistent with what we're dealing with here. So if you ever kind of forget these things, you can always go back to these sort of basic equations. This is a parabola that opens to the right. Our y term is squared. We have a positive coefficient, and that's consistent with what we're dealing with here. So that's just a quick little thing I'd figure I'd mention. The other thing we can identify by just looking at the equation of a parabola, if it's in this form, is the vertex, right? We can always quickly identify the vertex, which is hk. And I want to point out that the h always follows the x. So it doesn't matter whether the x term is squared or the y term is squared. The h is going to be next to the x, and the k is going to be next to the y, right? The term being squared doesn't affect that. We always get our vertex that way. So that's another thing we can identify. And third thing is this value a, right? Which, as you get some practice with this, you'll be able to just look at these equations and immediately tell what a is by simply just dividing the coefficient by 4, right? And we never take the negative along with a. A is always positive. That's why we have this plus or minus here. But what a tells us is the distance from the vertex to the focus, as well as the distance from the vertex to the closest point on the directrix, which is sort of a line that is behind the parabola. That's kind of an informal way of explaining it, but that's how I think of it, and you'll see what I mean once we get into our first example. But hopefully this makes sense. I figured I'd just give a quick explanation of kind of how I approach these problems, because this is the checklist I go through when I am given a parabola in this form, the equation of a parabola. I identify which direction the parabola is going to open, where the vertex is, and what a is. And then I start trying to sketch the graph. So that's what we're going to do in this first example. All right, so looking at our first example, we can quickly notice that our y term is squared and our coefficient is positive. So this parabola is going to open to the right. So I'm going to write opens right. And by the way, what I mean by open is that the U shape is going to be facing this way, right? Hopefully y'all are familiar with that terminology, but if not, that's what I mean. Our U shape is going to be opening to the right. What else can we identify? Well, we can get the vertex. In this case, my h is 2, and my k is -1, right? So here we have x minus h, so my h is 2, and here we can think of this as y minus -1. So I need my k to be -1. So I have opens right, I have vertex, and now I need to find the value for a, which, like I said, a lot of times you can just look at this and tell, oh, my a is 2, because 4 times 2 equals 8. But if you can't notice that, then you can actually solve this equation. 8 equals 4a, and that's pretty easy to do by just dividing both sides by 4. But I think y'all can look at this and see that a equals 2, and I can leave it at that for the rest of these examples. So given this information, this is actually enough for us to start sketching this graph. And there are different ways, I'm sure, to go about this process. This is just what I do, is I get this information and then I start plotting points. And really the first point I can plot is the vertex. So our vertex is here at 1, 2, -1. So right here, and we know that this opens to the right. So I'm going to go ahead and draw my U shape. Something like that. My drawing skills are not the best, just warning you right now. Something like that. So this is sort of what our parabola looks like. And if you want to be really accurate, you could actually find this x-intercept. It just depends on what your instructor expects out of you, right? If you want to be really precise, you could find this point. You could do that kind of stuff. I'm just going to keep it at a general sketch. So now what I can do is gather some more information. I really want to find the focus. I want to find the directrix and the axis of symmetry. So the axis of symmetry is actually pretty easy to find. And you could sort of tilt your head to the right and see where this parabola is symmetric, about which line. And maybe I'll draw this line in blue. It's this line here, this horizontal line. And our axis of symmetry actually always goes through the vertex and the focus. And it actually intersects as well with our directrix perpendicularly, if that makes sense, which we'll see in a second. So I can actually write the equation of this line. So axis of symmetry is the line y equals -1, right? So hopefully that makes sense about how I got that. Now I need to find, let's see, the focus and the directrix, and I'll be done. So the focus I can get by using this value a, and the directrix I need this as well, right? Because the distance from the vertex to the focus is a, so 2. And since the focus lies on this axis of symmetry, I just go a distance of 1, 2. I'm going to use a red point. Boom. And there is my focus. So focus, let's see, x equals 4, y equals -1. And this is why I like jumping to the graph first, because in my opinion, it makes it a lot easier to get these exact points and equations and make less mistakes. But that's just my opinion. You can do it however you want. So now the directrix, we can use a similar method. We go a distance of 2 backwards, right? That's why I said it's kind of behind the parabola. And that's going to give us a point on the directrix, which is going to be this vertical line. So it actually turns out to be the y-axis, but I'm going to define it as x equals 0. Directrix is the line x equals 0. And I think that's everything we needed to find for this example. We found the vertex, the focus, the directrix, and the axis of symmetry, and we did a rough sketch of the graph. So I think that should be enough, and now let's go ahead and move on to our next example. So the reason I put this example in here is because the first thing we could probably notice is that it's not in the form we want it to be in. So first we actually have to do some manipulating and get this equation in the form we want it to be in, so we can identify the vertex, which direction it opens, those sort of things. So we have to do something called completing the square. And there are different ways to do this. I'm going to show the way I do it, and if you do it differently, that's totally fine. But what I first notice is that my x variable is the thing being squared. I don't have a y squared in here, I have an x squared. And my general equation that I want this to be in is something like x minus h squared equals plus or minus 4a, all that stuff, right? But I really want that x minus h squared equals something. So I'm going to take all of the terms that don't have an x and move them to the other side and keep my x terms on the left-hand side. That's my strategy I'm going to start with. So that means I'm going to take x squared plus 6x and keep those on the left-hand side. But I'm going to move 4y and 1 to the other side. So I'm going to essentially subtract 4y from both sides and subtract 1 from both sides. And I'm actually going to move this out of the way because I want to make room, because now I'm going to do something called completing the square. Because again, I want this to be a binomial squared. So really what I want to figure out is what can I add in here that will allow me to factor this into a binomial squared. And how we figure that out is we look at this coefficient for x, which is 6. We divide that by 2, which gives us 3, and then we square that, which gives us 9. So I can add 9 in here, and then to balance the equation, I need to add 9 to the other side as well, right? Make sure you do that. And now what I can do is actually factor this into x plus 3 squared equals negative 4y, let's see, minus 1 plus 9, that's plus 8. So now on the left-hand side, I have what I want as far as a binomial squared, but on the right-hand side, I want to factor this side as well because I want it to be something times y minus k, right? So I need to factor out this negative 4, and it does work out nicely because this 8 is divisible by 4, and it should always work out that way, otherwise could get messy, or maybe double check your work if it doesn't work out that way. So I'm going to factor out this negative 4, and this is how I like to do it. Draw my negative 4. I know that y is going to be here, and now I need to think about what can I put here to make sure when I distribute this back in, I get exactly what's above it. And it turns out that I need a minus 2 because negative 4 times negative 2 gives me 8, and negative 4 times y gives me negative 4y. So this is exactly equivalent to what we just had. Now I can just erase and move this up. And now we have the equation in the form that we want it to be in, where we can start identifying which direction this parabola opens, the vertex, and all that stuff. So hopefully that process makes sense. It's completing the square. I'm going to move this up here and let's start working with this. All right, so now what we can notice is that our x term is squared, right? And we have a negative coefficient, so that means this parabola actually opens down. Okay, so it's going to be like an upside down U shape, like this. Hopefully y'all can see that. Upside down U, okay? So what else can we identify? Well, our vertex is going to be where? Let's see. X minus h, right? So that point needs to be, I could think of that as x minus negative 3, and then y minus k, so that's positive 2. So we have our vertex at negative 3 comma 2, and what else can I gather from this? My a is actually equal to 1, right? And again, I could solve the equation, 4a equals 4, divide both sides by 4, but a equals 1 in this case. Now I can start sketching the graph and see if I can gather the rest of the information I want based on this sketch. So let me see if I can draw some straight lines here. I always struggle with drawing straight lines. On the iPad it makes it harder, honestly. Alright, so let's see, what do we have? The vertex is at negative 3 comma 2. So 1, 2, 3 in this direction. And then up 2. This is going to be my vertex. And this is going to open down. So I can actually go ahead and draw a parabola that opens down. And again, if you wanted this sketch to be like super accurate, you could find these x-intercepts and label them. Check with your professor and see how accurate they want this to be. But now let's see if we can find our axis of symmetry. I think that's what we did first last time, so we'll just be consistent. So this time our axis of symmetry is a vertical line, right? And it's actually the line, let's see, axis of symmetry is the line x equals negative 3. So that means that my directrix is going to intersect with this line, and my focus is going to be on this line. And my focus is going to actually be on this line a distance of 1, because my A is 1, away from the vertex. So my focus is actually going to be this point here, right? A distance of 1 away. So what point is that? Let's see. Focus is at, let's see, what point is that? Negative 3 comma 1. Negative 3, 1. There's my focus. And now what do I have left to find? Just the directrix, right? Which I can find by going a distance of 1 in the opposite direction. So it would be this line here. And I'll draw it, I guess I'll draw it in blue. So this line here is actually my directrix. I'm drawing it as a dotted line. I should make it a solid line. There we go. And as you can see, it's sort of behind the parabola. I don't think I drew it last time, probably because it was on one of the axes. This time it's not. So now our directrix is a horizontal line, and it's actually the line y equals 3. That's our directrix, right? And we have our graph already sketched where we have our focus, our vertex, and our directrix, and our axis of symmetry all on the graph. So I guess technically you can go and label these things, but since I'm writing them out here, I figure that's enough. But hopefully this makes sense. We're going to get into some more examples. So let's go ahead and do it. So for these next two problems, we're sort of working in the opposite direction than we did the first two problems, right? This time we're being given information about the graph of a parabola, and we're being asked to write the equation and sketch a graph. So in these examples, what I actually like to do is similar to what I did before, which is start with the graph. Let's use this information. Let's plot these points, and let's see if it makes a little bit more sense once we look at these 2 points. And I think you'll see why I do this, hopefully. I really do it because it makes it make a little bit more sense than trying to go straight to the equation. It also prevents some pretty silly mistakes that could potentially happen. I just like doing this a little bit better. But again, if you have a different method that works, that's totally fine. So I'm going to plot 4, -2, and I'm going to do it in red. I think that's what I've been doing, is the focus in red. And then I'm going to go along to 6, -2. And I'm going to do this in black because this is the vertex. And now let's notice that I have the vertex to the right of the focus. So that means this parabola is going to open to the left because my parabola always opens toward the focus, right? So this parabola is going to open to the left, and that's why I like to plot these points and kind of visually see it, because it's harder to see that just looking at the points as they're written. So now I know that this opens to the left. I have my vertex, I have the focus. I know that the distance between the vertex and the focus is 2, and I can get that by just looking at the graph, right? So that means my directrix is going to be, let's see, 1, 2, and again, it's a vertical line sort of behind the parabola. So this is going to be my directrix. And I don't think I actually need that for this example. It doesn't ask for it. I just need the equation and to sketch a graph. But I guess this completes the sketch of the graph, since now we have the directrix, the vertex, and the focus. And now we just need to find the equation. So since we're opening to the left, I know that my y term is going to be squared. So it's going to be in this form y minus k, where k is the y coordinate of the vertex. So the y coordinate of the vertex is -2, so I have y minus -2, which gives me y plus 2. So this is my squared term. And this equals negative, since we're opening to the left, right? This coefficient has to be negative. And then what I have is -4 times a. And in this case, we've noticed that our a is 2, because that's the distance from the vertex to the focus. So I have 4 times 2, that's 8. And now let me move this a little bit to make a little bit more room here. So I have -8, and then I have x minus h. So what is my h? Well, that's the x coordinate of the vertex. That's 6. And that should be it for the equation of this parabola. And I've also sketched a graph. I guess I could label some of these points. These tick marks on the axes kind of take care of that, but if you want, you can go through and label some of these points. But hopefully that makes sense. Hopefully y'all like that method of kind of plotting the points first. I'm a big fan of it. And I'm going to do the same thing with the next example as well. So this time, instead of being given the focus and the vertex, we're just given the focus and the directrix. So let's see if we can use this information to find the equation for this parabola. So let me draw my y-axis here. Let me draw my x-axis here. And I'll go ahead and draw the line y equals -1. That's just 1 down here. And I've been using blue for the directrix, so I'll be consistent with that. So this is the line y equals -1. That's my directrix. And the focus is at -2, 3. So -2 in this direction and 3 in this direction, and I think I've been using red for the focus, so I'll use red again. So now I need to think about how can I find the vertex, right? And this is when it's useful to notice that this value of A, that's the distance from the vertex to the focus, remember that's also the distance from the vertex to the directrix. So that means the distance from the focus to the directrix is 2A. And another way to think about that is that the vertex is always halfway between the focus and the directrix. So whatever this full distance is, my vertex is going to be halfway between it. And I believe this full distance is 1, 2, 3, 4. So my value for A is going to be 2, and my vertex is going to be right here. And again, the parabola always opens up toward the vertex, right? So in this instance, my parabola is going to open up like this. Like this. So something like that. Not the best sketch, but that's okay. I'm not being graded on how good of an artist I am, just as long as I sketch a graph and get the equation, right? So my A is 2. I'm given the focus. Let's think about what my vertex is. And once I write this out, I should be able to come up with the equation. So the vertex in this case is -2, 1. And again, this is why I like going straight to the graph, because then I can easily find these points, find my value for A, that sort of thing, find out what direction it opens. So what's the general equation for this parabola? Well, let's see, we're opening up, so our x term is going to be squared and our coefficient is going to be positive, right? So we're going to have x minus h squared. So what is my h in this case? That's the x coordinate of the vertex. So that's -2. So x minus -2, that's x plus 2 squared. And this is going to equal positive 4 times A. So that's positive 8 times y minus k, which in this case is 1. And there we go. It's that simple. We have the equation for this parabola. And that's it. That's the last example. So hopefully you got something out of this video. Hopefully these examples make sense. If you have any questions, let me know in the comments below. And be sure to keep flexing those brain muscles. I'll see you on the next video.